Hello dear viewers, today we are looking at a method of row reduction to echelon form, but remember to subscribe if you have never subscribed. Now before we dive into this one, let's first establish the answers using a calculator. Hope my calculator is very visible. So you look for mode on your calculator, you press it until you find the word equation, then press 1, then choose 3 unknowns. Then the first A1 is this value of the coefficients are what we are going to feed in. So A1 is 1, then press equals, then the B1 is -2, press equals, then C1 is -2, press equals, then D is 0, press equals, then A2 is 2, press equals, then B2 is 3, press equals, then C2 is 1, press equals, then D2 is 1, press equals, then A3 is 3, press equals, then B3 is -1, press equals, then -3 for C3, press equals, then feed in 3. So it has given me X is equal to, so X is -2, then Y is equal to 3, then Z is 4. Z is -4. So before you solve, ensure that you have those answers right there. So I've used the calculator. So let's dive into the row reduction to echelon form. We have to first write the matrix form. So matrix form. So you write the coefficient. So I have 1, -2, -2. Here I have 2, 3, 1. Then I have 3, -1, -3. Then close this. Then close that. Write the values of x, the letters x, y, and z. Then I close like that. X, y, z, then is equal to 0, 1, 3. So you write that. Then from the matrix form, we write what we call augmented matrix. So augmented matrix. So we extract the elements, these ones. So I'm going to have 1, 2, 3. Then these ones, -2, 3, -1, then -2, 1, 3. Then extract the other element, then close the matrix. It's called the augmented form. Then we transform this augmented form to echelon form or to a triangular matrix. So the echelon form, we mean we are going to make all elements below this leading diagonal to be 0, this position to be 0, this position to be 0, this position to be 0, or we can use the upper elements above the major diagonal, these ones here. So the order of making 0, we shall make this one 0, followed by this, followed by this. For upper elements, we make this 0, followed by this, followed by this. So let's now convert it into echelon form. So close down that. This is 1, 2, 3. -2, 3, -1, -2, 1, -3. So we are converting it to echelon form. Let's use the lower elements, this to be 0, but we start with this, followed by this, then finally this by performing row operations. So let's operate on this to make this 0 and this 0 at the same time, or we can operate first on this, then we go on this, then next stage we go on this, but there we will be wasting time. So let's say we are operating on row 2 also. So row 2 is going to be transformed by doing what? So row 2 minus row 1. Even row 3 are going to transform it by saying row 3 minus row 1. So the easiest way to do it is always, this is the general form that can be easily used. Can always say row 2 minus row 1, row 3 minus row 1. But row 3 can also use row 2 to operate on it. But this is the most easiest way to remember. So we are just going to swap the coefficients. So row 2 with row 1. So I'm going to swap the one on row 2 to put it here. Then the one on row 1 to put it here. This is 1, but I might not as well indicate it. Then I'm swapping between row 3 and row 1. So I'm here. So the element, The one for row 3, I'll put it here. Then this one, I'll swap it here. So if there was a 4, you'd put here 4. But this is 1. So this is the easiest way to remember. Always have row 2 minus row 1, row 3 minus row 1. Or this can be row 3 minus row 2. And you also swap the elements like that. So let's try to operate on those. So the first row 1 is unaffected. We write it as it is. This -2, 0. So these are going to be 0 definitely. You don't need to waste time checking up. Now let's operate row 2. So I'm starting with row 2 here. Work on it. The first position, I need the element for this. So row 2 minus 2 row 1. So it is 3 minus 2 times row 1, which is this. So this gives us 7. Then the next position is this position here. This is row 2, which is 1. Then minus 2 into row 1, which is this. So this gives us 5. Let's go on this element. So I have 1, which is row 2 minus 2 into row 1, which is 0. Gives us 1 here. Now checking on, row 3. Let's look at row 3. So this position here. So I have row 3 minus that. So row 3 is -1 minus 3 into row 1, which is -2. So this gives us -1 plus that, which gives us 5. So again, we are looking at row 3 again, this position here, -3. Now row 3 minus this, minus 3 into row 1, this is that. So this is -3 plus 6 gives us 3. So let's now look at the last element. This is 3. This is row 3 minus 3 into row 1, which is 3 into this, which is 3 minus 3 into 0, which is 3. So we have operated on that. Now, if there is any common element, we always divide through, but I can't see any common element. That's why I'm going to make this position 0. So again, operation row 3 is transformed into. So I'm going to use, when you are performing the last operation on row 3, only use row 2. If you use the row 1, it will affect this position here. So I'm going to say row 3, it will be row 3 minus row 2. So I look at the elements and I interchange them. So on row 3, I have 5, so put 5 on row 2. Then swap this one and put it here. So let's now look at the elements. So first row is unaffected, so I have 1. This is 0. So this is 0. Even the second row is unaffected. Remember to label these rows as row 1, this is row 2, this is row 3. So this, now this position is 0. So this is 0 exactly. So let's now only work on this. So I'm now working on this place here, which is a 3. So it is 7 times row 3. 7 times 3 minus 5 times this. That gives us 21 minus 25, which is -4. Now let me look at this position here. So that is 7 times row 3, which is 3, minus 5 times row 2, which is 1. So this gives me 21 minus 5, which is 16. So now there is a common element here. We can transform again row 3. So row 3 becomes, there is a common element of 4. So row 3 becomes that. So then let's first have this. This is 116. So this we are dividing through by 4. So this gives us -1. This is 4. So this position is for z. So it's negative z is equal to 4. That means z is -4. So right there. So this position is for y. So I can say 7y plus 5z is equal to 1. When you feed in the value of z here, so it will be 7y plus 5 into -4 gives you 1. So your y will actually be, y value will be actually, the y value will be 3. Then at that point we can go for x as x minus 2y minus 2z equal to 0. So when you solve for that, so this is y is 3 minus 2 into z. Z is negative 4. If you equate to 0, you get your x as actually negative 2.